Now, this is the second class on chemical bonding. You know, the first video that we dropped, we said that I'm going to be breaking down the video stage by stage. So if you know, say you never watched that first video, correct guy, go watch and go there. It's in my channel already. My name is Mosjaro. And if you know that you're coming across this video anywhere you are, make sure that you press the subscribe button, because I'm going to be dropping points back to back. Now, this series of video is specifically for persons that are having difficulty in chemistry. So if you're having difficulty in chemistry, in biology, this is a channel, of course, that you need to tune into. Of course, I also upload videos here on medical biochemistry, on anatomy. This channel is what you shouldn't miss at all. Now, very quickly, coming back to what we're saying, now we are dealing with chemical bonding. For those of us that are going to be preparing for the 2027 UTME or WAEC examination, or probably you are in XS1, XS2 high school and you're having difficulty in chemistry. Now, quickly, we started the video in the previous class with chemical what bonding. Now we have listed we have said what's bonding rather. We have listed the types of bonding. Why bonding occur? You see, we're not a jump into these things. We try and break it down step by step. Why do bonding occur? Now, again, we have listed the types of bonding. I've looked at electrovalent bond. But in looking at that electrovalent bond, remember in that class, we said that COMO is not all situations where we have metals and non-metals. There is always an electrovalent bond that exists. For example, we gave a good example. We made mention of the fact that what? Yes, aluminum chloride is the elements that form this compound. Is one of them is a metal, which is aluminum. The other is a non-metal, which is what? Chlorine. But that does not mean that the bond that exists within them is what? Is electrovalent bond. Though we stated that for electrovalent bond to happen, there must be a transfer. That's one thing you must put at the back of your mind. Transfer of what? Of electrons, usually from a metal to a non-metal. But now later went ahead to say that there are some exceptions. One of them is what I brought out here now, which is what? Aluminum chloride. Now, what's that exception? The exception says that what? That it's not all compounds that when there is metal and non-metal that we have a covalent bond. But this one exhibit what? Covalent what bond. And remember, some of the things that we also said again was that in covalent bond, ions are what? Ions are formed. You dey see am so. Now, fall back. We actually stopped in this angle after we were saying some things about electrovalent bond, that electrovalent compounds can be used as electrolyte. Electrovalent compound dissolves to form what? To form ions and all that. Please, these videos are meant for those persons that want to have detailed information, specific information about what? About chemistry. So you should pay good attention to my points. Now, look at this guy here, aluminum chloride. We have stated already from the previous video that the bond that exists here is what? Is covalent bond. Do you know why? There's a share of electrons here, not a transfer. Another reason is actually taken from what is regarded as what? As Fajan's rule. And that another reason is what? Due to electron what? Negativity. You dey see am so. Now, one thing I want you to put at the back of your mind as we start the class proper is that this electron negativity can be used to predict what? To predict type of bond. This is the first information that you must put at the back of your mind in today's class. That this electron negativity is used to predict type of bond, or electron negativity difference can be used to predict type of what? Bond. What do we mean by that? Now, ladies and gentlemen, boys and girls, there's what we call the electron negativity threshold. The electron negativity what? Electron negativity threshold. Now, I don't want my videos to be too long, but I will not rush it at the same time. Now, first off, you know what I want to do? What enter into my mind that some of you are seated there with your hair like Bambiala. You don't know what is electron negativity. So I cannot assume, because this is taking chemistry from the scratch. What's electron negativity? Is the tendency or ability of an element or atom to attract electron to itself. You understand? So ability or tendency of an element to attract electron to itself. That's what's what? Electron negativity. A little bit different from electron affinity. Almost the same, but a little bit different. Though they have the same variation with the periodic what? In the periodic table. Now, you have known what's electron negativity. Now, electron negativity used to do two things. Aside from the fact that it used to predict type of bond, number two can also be used to determine the what? The polarity of a what? Of a molecule. So, type of bond and polarity of a molecule can be determined by the electron negativity what? Difference. Show you the same now. So we have to be very, very careful. Now, how does this play? Now, when the electronegativity difference between two elements is what? Is above 1.77, is high. That means the bond that is formed is what? Is electrovalent bond or ionic bond. But when it is below 1 point, like this one now is 1.5, is what? Is what? Covalent, what? Covalent bond. So what am I trying to say? When the difference, summary, layman way, when the electronegativity difference between two elements, maybe we have element P and we have element Q. Show you the same. So when the electronegativity difference between two elements, let me say for example now in JAM, they usually give values. Maybe they will say if the electronegativity of element P is what? Is 5, and that of Q is what? Is 0.8. They will now say if P and Q combine together, what type of bond will exist between them? Definitely is electrovalent bond, but you can see the electronegativity difference is high. But if there is no difference, maybe this one is 0.8 and this one is 0.8, you see there is no difference in electronegativity value. That means what? The bond form is a covalent bond. Or probably if there's a difference, the difference is not up to 1.7. That means is what? Is covalent bond. So that's another reason why the bond that is formed between this guy is what? Is covalent bond, not what? Not electrovalent what? Bond. Now come back to me, come stay with me, come there. Now this aluminum chloride, and there's also you must know, please take note, aluminum chloride exists commonly in vapor state as a what? As a dimer. Now, if you are coming up in chemistry, you'll be like, say, oh, Mosjaro, don't speak big grammar again. No, don't worry yourself. Now, what's a dimer? A dimer means like from the word di, like two molecules joined together. That means to say this aluminum chloride usually exists in vapor state as what? As Al2Cl what? Cl what? 6. Now, this is the dimer. So this is the form in which aluminum chloride usually what exists. Now, this even throws more light on the fact that the bond that exists here is what? Is covalent, what? Is covalent bond. So reason why is this bond here covalent? There's a share, applying Fajans rule, electronegativity, and again another difference is that now coming back, I want to state something. I've showed you something now, threshold, negativity threshold. Please don't forget that thing that I just said just now. Make sure that you put that at the back of your mind. Then I don't want to stress too much. Let's now look at covalent bond. Because you know, if you know that you missed the first video, that's why you sure you go and I listed this type of bond. And later went to say that we have intermolecular force, which are the weak forces. Now, what are the weak forces? Now, you forget hydrogen bond. Now, you forget dipole attraction. Now, you forget what van der Waals, which is the weakest intermolecular force. Now, I want to look at covalent bond. What type of bond is covalent bond? What are formed in covalent bond? How is covalent bond formed? What are the properties of covalent compounds? Like I've listed the properties of electrovalent compound. I said number one, they decompose to form ions. Number two, they are strong electrolyte. That means they conduct electricity in aqueous states. Show you the same now. They usually exist in what? In solid states. Usually. Now, these are properties of electrovalent compound. Just want to do a quick review so that the class will make more sense to you. Now, let's look at covalent bonds. How are covalent bonds formed? And what are the properties of covalent bonds? And what are the compounds that can exhibit what? Covalent bond. Oyamoko jump through sharp sharp. With my duster, make a clean but time no day. So, ladies and gentlemen, let's look at what? Covalent bond. What is covalent bond? Now, first of all, covalent bond is a bond that is formed when there's a what? When there's a share. Unlike the other one where there's a what? A transfer. So this one, in covalent bond, there's a share of what? Share of electrons. And you know fully well that to form one bond, one electron, one electron. So when there's a share of electron, how far you bring, or one person bring, two of them share. Now we now have what? Covalent bond. But please, there are two common categories of covalent bond. There's what we call the what? The ordinary covalent bond. You dey see am, and the what? And the coordinates covalent what? Covalent bond. The video is becoming very long. I need to cut it here, but please, I need to explain something very, very fast. Now we have the what? Ordinary covalent bond and the coordinate covalent bond. Now we said that covalent bond involves the share of electrons. Abi, another thing you must know that in covalent bond, molecules are formed in covalent bond. Unlike in electrovalent bond where ions are formed. Another thing you must know again is that covalent bond usually exists between what? Between non-metals. Unlike in electrovalent bond that exists between a metal and a what? And a non-metal. But this one usually exists between what? Between metals. Though exception, carry your mind, go aluminum chloride. You see, you have to be very, very careful. Now, Covalent compounds. Let's now go now. Covalent compounds are usually what? Are usually weak electrolytes. You see, I'm so are usually weak electrolytes. So that those compounds that are formed from covalent bond are usually weak electrolytes, and even some of them are non-electrolytes. Sure, you get them now. And covalent compounds usually exist in what? In gaseous or liquid states. Sure, you get them now. So these are things that you must put at the back of your mind when it comes to what? Covalent bond. What are formed during covalent bond? Molecules are formed. And covalent bond usually formed between non-metals. Sure, you get them now. And again, covalent compounds are usually weak electrolytes or sometimes non-electrolytes. Now look at the either in gaseous form or in what? Liquid state. Now come. Now there's something you need to know. I want to introduce here before we now bring another point out. That in ordinary covalent bond, remember, this electron, two electrons forms one bond, yeah? In ordinary covalent bond, look at what happens. The electrons that are shared are donated equally by the two combining species. What do we mean? Let me say we have an element P and we have an element Q and want to form covalent bond, and they need two electrons. The electrons that are going to be shared will be donated equally by the two combining atoms. That means you bring one, we share. You're seeing it now. Because me, I need to be complete. This guy needs to be complete. Remember, our rule here is that for bond, why do elements combine together in order for them to attain what? Stability. Now, this is just a preamble of what you should know. We are going to break it down. That's why I said this video on chemical bonding, we have series. Now, this core ordinary covalent bond, I said, involves what? The share of electron, yes. But the electrons that are being shared are donated equally by the combining species or elements or atoms. Why in coordinate covalent bond, which is also known as what? Is also called dative bond. Is also known as dative bond. Is what? Is a type of bond in which the electrons that are being shared are donated only by one of the combining species. Show you the get now. So that is what is called, that is the simple difference between what? Ordinary covalent bond and what? Coordinate covalent bond. So in our next class, we're going to be throwing more light on how are they now formed. Examples, we're going to break it down very quickly. So ladies and gentlemen, my name is Mosjaro. You're coming across my video for the very first time. This is a channel that you shouldn't miss at all. And again, I used to say that you should try and add the what? Effective what? Chemistry and effective what? Biology, authored by my very self. So if you want a copy of that book, make sure you send a DM or you place a comment in the comment section. So please, if you are watching this video, do well to share so that other persons can get to watch and get to follow up. And please send me a DM on my WhatsApp number. It's in my bio, because I'm organizing a WhatsApp group so that we'll begin to throw points and interact with ourselves. So ladies and gentlemen, thank you for watching. I'll see you in my next video. Ciao.